Welcome to the final section of Chapter 1, Data Communication Fundamentals. In this session, we will focus on the digital data transmission formats, transmission impairments, and transmission modes. These concepts explain how data moves across networks and the challenges that affect the communication quality. We began with the digital data transmission formats. In computer networking, information consists in two main forms, analog and digital. An analog data is continuous, such as human voice or temperature, that changes over time. Digital data, over the other hand, is discrete and represented using binary values, typically which is zeros and ones. Both analog and digital information can be carried using signals. Digital signal consists of discrete voltage pulses used in computer systems, while an analog signal is continuous and varies smoothly over time, often represented by electromagnetic waves. Since computers cannot directly process continuous analog signals, they must be first converted into digital form. This process is known as digitization. Digitization transforms real-world signals such as speech, music, images into binary data that can be stored, processed, and transmitted efficiently within a computer system. Next, we examine digital to digital conversion. This refers to the representation of digital information using digital signal. In this process, binary bits are translated into voltage pulses for transmission over a communication medium. Several encoding techniques are used, including the unipolar, where a single voltage level represents binary values. Polar encoding, which uses both a positive and a negative voltage levels, and the bipolar encoding, which alternates positive and negative signals to represent binary 1, while 0 is represented by no voltage. We also consider analog to digital conversions, which is the process of transmitting continuous analog signals into a digital conversion, which reduces signal complexity and makes data less susceptible to noise. Two common techniques used in this process are the pulse amplitude modulation and the pulse code modulation, which sample and encode analog signal into a binary sequence. Now we turn transmission impairments, which are factors that reduce the quality of a transmitter signal. As data travels through a communication medium, it affects by several forms of degradation. The first is attenuation, which is the loss of signal strength as it travels over distance. This occurs because parts of the signal energy is lost as heat. To overcome attenuation, amplifiers are often used to boost signal strength. The second is distortion, which occurs when different components of a signal arrives at different types or speed. This changes the shape of the original signal and can affect data accuracy. The third is noise, which refers to unwanted signals that interfere with the original transmission. Noise can come from many sources, including thermal noise, electromagnetic interference, crosstalk between wires, or sudden spikes such as lightning. Finally, we explore transmission modes, which describe how data is transmitted between devices. In parallel transmission, multiple bits are sent simultaneously, making it faster over short distance. In serial transmission, data is sent one bit at a time, which is more reliable over long distance. Serial transmission includes in three types. Asynchronous transmission sends data with start and stop bits for synchronization. Synchronization transmission sends data continuously without start and stop bits, which require precise timing between the sender and receiver. For isosynchronous transmission, ensure that data is delivered at a constant, steady rate, which is important for real-time applications such as audio and video streaming. In terms of a communication flow, transmission can be simplex, half duplex, and full duplex. Simplex communication is one way only, such as a keyboard sending data to a computer. Half duplex allows both devices to transmit and receive, but not at the same time, as in the walkie-talkie. Full duplex allows simultaneous two-way communication, similar to modern telephone systems. By the end of this chapter, you should be able to explain digital data transmission formats, identify different encoding techniques, describe transmission impairments, and distinguish between various transmission modes used in computer networks. See you in the next chapter.